Chapter 1, Chemical Reactions and Equations, Module 2, Balancing Chemical Equations. Is there a change in mass when a chemical change or a chemical reaction takes place? To answer this question, let us try to recollect the activity 3.1 that you had studied in class 9, chapter 3, Atoms and Molecules under Law of Conservation of Mass. Please look at the figure when the activity is being described. After preparing separately 5% solution of sodium sulfate and barium chloride in water, a little amount of solution of Y, here sodium sulfate solution, is taken in a conical flask, and some solution of X, here barium chloride solution, is taken in an ignition tube. The ignition tube is carefully suspended into the conical flask with the help of a thread. The conical flask is tightly closed with a rubber cork. Can you give the reason for tightly closing the conical flask with a rubber cork? The flask is weighed with its contents carefully. Then the conical flask is tilted and swirled in order to mix the solutions of sodium sulfate and barium chloride. The flask is weighed again with its contents after the reaction between the solutions of sodium sulfate and barium chloride. You would have observed that mass of the flask with its contents before the reaction and mass of the flask with its contents after the reaction will be the same. That is, mass is conserved. Based on the activity just described, try to answer this question. What will be the observable change when solutions of sodium sulfate and barium chloride are mixed, which indicates that a chemical reaction has taken place? In the activity just described, a stoppered conical flask can be considered as a closed system. No substances can enter or leave a closed system. The reactants and products stay inside the stoppered conical flask itself. The total mass of the stoppered conical flask and the substances it contains stays the same during the reaction. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Though many people, including the ancient Greeks, laid the scientific groundwork necessary for the discovery of the law of conservation of mass, it is French chemist Antoine Lavoisier who is most often credited as its discoverer. This is also why the law is occasionally called Lavoisier's law. The discovery of the law of conservation of mass was immensely significant to the field of chemistry because it proved that matter wasn't simply disappearing as it appeared to be, but was rather changing form into another substance of equal mass. So, to state the law in a slightly better way, in a closed system, matter can neither be created nor destroyed in a chemical reaction, it can only change form. Chemical equations can be made more concise and useful if we use chemical formulae instead of words. Chemical reactions are best described by balanced chemical equations. The starting materials of any chemical reaction are called reactants, while the new substances formed are called the products. According to law of conservation of mass, the total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance an unbalanced chemical equation, also called as skeletal chemical equation. For this, count and compare the number of atoms of each element on the left-hand side and right-hand side of the arrow. Find out if the number of atoms of each element is the same on both the sides, reactant side and product side. If not, then the equation is unbalanced because the mass is not the same on both sides of the equation. Then put the coefficients appropriately in front of the atom or molecule in order to balance. If the numbers of atoms of elements on both sides of an equation are equal, only then an equation is said to be balanced. This method of balancing chemical equations is called hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Some important points to be considered while balancing chemical equations. Write the correct chemical formulas for all the reactants and products. Coefficients are the numbers that are put in front of a molecule. Coefficients are not to be put in the middle of a molecule. Never change numbers that are already part of a chemical formula. Never add subscripts to a chemical equation to balance it. A polyatomic ion that appears unchanged on both sides of the equation is counted as a single unit. Finally, make sure that all the coefficients are in the lowest possible whole number ratios. Slides 6 and 7 will help you recollect what had been already studied in class 9. So, spend some time in going through these two slides. Let us try to balance the following equation which has been already discussed in module 1. Magnesium reacts with hydrochloric acid to give magnesium chloride and hydrogen gas. Word equation and skeletal equation are given. The skeletal equation is an unbalanced chemical equation. The number of atoms of each element should remain the same before and after a chemical reaction as per law of conservation of mass. Please concentrate on the slide when explanation is being given. If we consider magnesium atom, there is one on the left hand side of the arrow, reactant side, and one on the right hand side of the arrow, product side. But there is one chlorine atom on the left hand side of the arrow and two on the right hand side of the arrow. Similarly, there is one hydrogen atom on the reactant side and two on the product side. So here, as you see, there is no need to balance magnesium atom, but both chlorine atom and hydrogen atom have to be balanced. In order to balance chlorine atom, the coefficient 2 is put in front of HCl. Once this is done, there are two chlorine atoms on the left hand side and two chlorine atoms on the right hand side. Fortunately for us, when the coefficient 2 is put in front of HCl, hydrogen atoms also get balanced. Now, there are two hydrogen atoms on the left hand side and two hydrogen atoms on the right hand side. The number of atoms of magnesium, chlorine, and hydrogen has now been balanced. Now, we can say the equation is balanced. Let us try to balance another chemical equation. Iron metal reacts with steam to form iron 2,3 oxide or ferrous ferric oxide and hydrogen gas. Word equation and skeletal equation are given. Number of oxygen atoms on the left hand side is 1 and on the right hand side 4. Therefore, coefficient 4 is put in front of H2O. Now, number of oxygen atoms become 4 on the left hand side and 4 on the right hand side. When coefficient 4 is put in front of H2O, then the number of hydrogen atoms on the left hand side becomes 8 and on the right hand side there are 2 hydrogen atoms. Therefore, in order to balance hydrogen atoms, coefficient 4 is put in front of H2. As a result, number of hydrogen atoms on the right hand side becomes 8. But number of iron atoms on the left hand side is 1 and on the right hand side 3. Therefore, coefficient 3 is put in front of Fe. The number of atoms of iron, oxygen and hydrogen has now been balanced. Hence, the given equation is balanced. Some balanced chemical equations are given below for you to refer. 1. Manganese dioxide reacts with hydrochloric acid to give manganese 2 chloride, water and chlorine gas. 2. When lead 2 oxide is heated with carbon, it is reduced to lead metal and carbon is oxidized to carbon dioxide. 3. When dilute hydrochloric acid is added to iron filings, hydrogen gas and iron 2 chloride are produced. 4. Hydrogen gas combines with nitrogen to form ammonia. Potassium metal reacts with water to give potassium hydroxide and hydrogen gas. To make a chemical equation more informative, the physical states of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by the notations G, L, AQ, and S respectively. For example, iron metal reacts with steam to give iron 2,3 oxide and hydrogen gas. Calcium oxide reacts with water to form calcium hydroxide. The word aqueous AQ is written if the reactant or product is present as a solution in water. Usually, physical states are not included in a chemical equation unless it is necessary to specify them. Sometimes, the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above and or below the arrow in the equation. For example, carbon monoxide reacts with hydrogen gas at elevated temperatures and at a pressure of 340 atmospheres in the presence of a catalyst to give methanol or methyl alcohol. In the process of photosynthesis, carbon dioxide reacts with water in the presence of sunlight and chlorophyll to form glucose and oxygen gas. Slides 12 and 13 contain equations for you to practice, and you are also expected to convert all the word equations given in Module 1 into balanced chemical equations.